This conference will now be recorded.
So, good morning, all, and welcome back to the session that is Big Data Masters program. And we are going through with distributed processing with PySpark. So, in previous session, what we have seen with respect to the file formats, and what we have seen in that particular session, like file formats uh, are broadly divided into two categories: row oriented file format or row based file format, and second one is the column based file format. And what we have seen over there, like certain file formats are providing faster read, some file formats are providing faster write, some are having good, you can say, compression, some are meant for better schema evaluation. And we have discussed many things with respect to, say, how the data is placed onto the disk with respect to these file format. And then we have discussed about certain splittable file format, and splittable are nothing but row based file format, and we have discussed, say, text file format, CSV, XML, and JSON. All of these are row based file format. Then we have seen big data world file format, that is nothing but the column based file format, and Avro, ORC, and Parquet. These were the three file formats we have discussed in our previous session. And we were able to differentiate among these particular file formats, and it will be depending upon our use case which format we need to prefer. That is the design level decision that we need to make. Then we have seen certain joining related stuff, how the joining is possible. And over there we have seen, we have applied the join based upon two data frames, or we have read two CSV files, that is small flights data and planes information. And with the help of that, we were able to get the informations planes running with one engine or two engine. So that was the stuff what we have seen in our previous session. In today's session, we will discuss about Spark SQL. Spark SQL. You just need to recall uh, the architecture of Spark, and what we know, like the architecture is divided into five main parts. At the bottom level, what we are having storage, and it may be, say, HDFS, okay, HDFS, S3, S3, then local storage, okay, any database, data warehouse, data, like it can be anything, okay. So storage can be anything. We just need to put the our data over there, and then we will be able to do we will be able to perform our operation. Okay, on to top of this, what we are having cluster manager, cluster manager. So with respect to the cluster manager, Spark is like having multiple cluster manager. It may be, say, K8, K8, that is known as Kubernetes. Then it can be Mesos, it can be Spark standalone, it can be yarn as well. So the cluster manager can be anything. Then Spark core is there. And with respect to Spark core, over here we are majorly talking about RDDs. Okay. So Spark core is nothing but dealing with RDDs. Or let me mention RDD only. On to top of this, we are having certain APIs. APIs basically say we are having data frames, data frames, or certain libraries, you can say. So in order to work with Spark, we are having certain libraries. Say data frame, that is higher order API, Spark SQL, that is another API. We are having MLlib, okay, that is in order to deal with machine learning algorithm, in order to apply machine learning algorithm onto top of the data, then we are having GraphX. GraphX, this is like another library which is given by Spark in order to deal with graphical data. Then on to top of each and everything, we are having programming language. Programming language. And Spark is like having the beauty to work with different programming language. It may be Python, it may be Scala, it may be Java or R. So these are, you can say, 5 layers what we have learned with respect to uh, Spark. And over here, what we are able to see Spark SQL, and that's what we are going to learn in today's session. So Spark SQL, basically, what is happening in today's world? Like most of the persons are having the knowledge to work with Spark, to work with SQL, and this Spark is going to give you the liberty. If you are having the knowledge of SQL, then you will be able to take the benefit of Spark. You will be able to take the benefit of distributed computing if you are having the knowledge of SQL. So over here, we are going to read the data with standard API, reading data, reading data, then processing. These are the 3 things what I used to mention in each and every session, and then writing the output. Okay, output. So what is happening for reading and writing? We are going to leverage Spark standard APIs, read API and write API. And for processing perspective of that particular data, we are going to leverage Spark SQL. Over here, we are going to utilize SQL-like queries in order to do the processing of our data. And how it can be possible? It is possible just by creating a temporary view. It is possible just by creating a temporary view on top of data frame. Okay. So in the previous session, what we have done, we were having uh, this particular date. You can say, let me copy this and paste it over here. This is day 18. Okay, so what we are having, we are having a particular, we have created a Spark session. Okay, and let me mention, say, week 12 and day 18. Okay, so day 18, this will be the application name. And what we are having, we are reading it with standard read API. This is small flights data what we are having in our machine, and then we are having planes information as well. Okay, so planes information, that is the another CSV file, and it is placed inside this particular machine, and we are reading that particular file as well. So what will happen once we are having data frames, then we are going to create temporary view onto top of that data frame. Example, so if we are having small flights data, that is a data frame what we are having, we just create a a temporary view, create or replace temp view. Okay, and we can give a view name, say small flights only. Okay, it can be anything, say table 1, table 2, table 3, whatever. It will depends on you, like what name you are going to give. for this particular view. So this view will be acting as a table name, and now you will be able to perform the SQL query onto top of this particular view. And you just need to leverage spark.sql in order to write down the queries in order to process this particular data with SparkSQL. Okay, so we have created a temp view onto top of this particular data frame, and let me mention over here small flights. Okay, let me copy from here only. Small flights dot create or replace temp view, and small flights, this will be the view name, and in the same fashion we can create the temporary view for planes data as well, huh? Now we are having two tables, huh? What I have mentioned, the small flights and planes data, that is a view, and it will act as a table, and now we will be able to perform SQL operations. Let me cut and paste it over here. So these are the two, you can say, data frames, views what we are having, and these views will act as a table. Now we will be able to run the SQL command onto top of these particular data frame views. So how it can be possible? Just have a look. Say, uh, huh, say small flights. Let me try to do something. Say spark.sql, and I just need to say select star from say small flights. Okay, and what I can do, I can say small flights data. I can create a data frame. So after this particular query, so I'm going to say run a simple query like select star from this particular table name, and I'm going to pass this particular outcome to this particular data frame. It will give you a data frame, and once I'm having a data frame, then I can definitely run this particular dot show command, dot show, and let me do the execution. So over here, let me mention, say, creating temp view from data frames. So we were having two data frames which we have read based upon the standard data read API, and now we have created the temp view, and over here we are trying to say do the processing. This is the second phase of our this Spark, you can say, data pipeline. And what we are having in data pipeline, say we are reading data, processing data, and then writing the output. This is like simple uh, pipeline what we are having. So let me do the execution and convert it to say current file. Okay, so the execution has been started at this moment. Okay, so okay, so the execution has been done. Now this is with respect to the first, you can say, .show function. Like we are trying to list top 20 records from the small flights. Then we we are like getting, we are displaying top 20 records of planes data. Okay, so these are the top 20 records of planes data. And then we have created a temp view, and from small flights we are like selecting, we are taking the top 20 records. We are like processing the table or view, and like moving the outcome to this particular variable, and that will be a data frame. And then we are executing dot show. So small flights data dot show, and we are getting the top 20 records. So this is like simple query. Now in previous you can say session, what we have done, we have uh, we have calculated, we have done the joining of small flights data with planes data. And then we have identified like uh, planes running with one engine, huh? So let's try to do the joining like operations with Spark SQL related stuff. Previously, we have done the execution of this particular, you can say, joining. Previously, joining was done with data frames. Now we are going to do the joining with simple SQL statements, huh? So we are having two data frames, sorry, two tables or view basically, that will be acting as a table, small flights and planes data. So we are going to apply the join now. Now, in order to, you can say, join, what we need to do, uh, say spark.sql. Let me first write it over here, and then I will paste it from here to there. So small flights, this is the first table, small flights, say
So one
spark.sql.
query here.
Mhm.
So every time we need to create one data frame first with the data. Then after that data frame we need to create temp view. So this is the every time for this Spark SQL.
Yes, yes, yes.
Every time we need to create
For
this
each
temp
and
view.
every, for each and every, you can say, data frame, we need to create the temp view that will be acting as a table, and then we will be able to apply SQL like operations.
Okay.
Okay, so Spark SQL, and what we are going to do is select star from, say, small flights. And what I will do, join with what, planes data, join planes data. And on what, small flights, inside small flights, what we are having, tail num, on tail num, and planes data equal to planes data dot tail num. This is the common field. On to this particular column, we are going to apply, this is the reference column basically, which is available into both of these two views or both of these two tables. So view and table, both of these are the same things. So no need to confuse on to top of this particular stuff. So small flights and planes data, these are two views or two tables. And what we are doing, select star from small flights, join planes data. On, we are performing the join, join plane data on small flights dot tail num equal to planes data dot tail num. And let me close this. Okay, and let me copy and paste it from here to here, and let me pass this particular outcome to, say, joined data frame. Okay, perfect. So join data frame, spark.sql, select star from small flights, join. So that is fine now. And let me try to list what is there in join data frame. So join data frame dot show. Okay, so like it is going to join both of these two data frame based upon this particular reference column. Let me do the execution. So execution has been started. And just have a look. Now, this is the first data frame, small flights data. This is the second data frame that we are having planes data. And this is the outcome, that is, you can say, join data frame, and it is the outcome of, you can say, after joining small flights and planes data based upon the tail num column. And we are having this particular entire data. Okay, now it will depends on you if you want to do the customization of this particular query. Like, you are not going to select the entire data, you are going to select certain columns only. So you can mention, say, select this particular this column, and then you can have those particular column, and that is, you can say, in order to you can say, improve the functionality. Like, if you are listing the entire data, definitely that will increase the load of the system, and a lot of, you can say, IO operations will be there. So what I suggest over here, this is an optimization as well. So you need to mention, you need to select the required column only. Okay, don't go with the star related stuff. Okay, now this is what we are having. We are having the joint data frame, but this is not as per our requirement. Like, uh, we want to have uh, the information about the flights, which small flights which are running with one engine only. Over here, like, two engines are there. Okay, might be three engine, four engines, so entire data set is there. But it is not, you can say, as per our, you can say, expectation. So what we need to do, we need to further, you can say, do the filtration related stuff. And what we can do, like, we can proceed with this particular stuff. Say, let me copy and paste it over here. So join data frame. So join data frame, join data frame, join data frame, has been two engines. Okay, that is fine. Over here, what we are doing, like, whatever the outcome we were having after joining, we are just like applying the filter. We are applying the filter operation. Okay, and then we are selecting the engines running, which are run, which like, selecting the data from this particular join data frame where, like, engines are less than two, and we will be able to get the outcome. And then we are, like, over here we are having repeated columns. So engines, and a particular column is repeating. Okay, I think year, the column year is repeating into both of, year is repeating. So because of that, like, it was it can create the issue while writing the data. So we are removing that particular repetition with respect to this particular functionality. We are selecting the unique columns only, creating the data frame based upon the unique columns, and then we are, you can say, writing the unique data onto the disk. So that is the stuff, like, with respect to SparkSQL. Now we are, this is the simple example what we have seen in our previous session, like how to get the information about flights which are running with less than, you can say, two engines, or which are running with one engine. So this particular, you can say, code will give you the information flights running with one engine. The execution has been started, and it has been done. It is still going on. Okay, and now I will be having the outcome based upon this particular code. Like I will be having the data, say flights running with one engine onto this particular path. Okay, if you want to say get the count as well, so you can get the count as well over here. You just need to, you can say, tune your operations, and you will be able to get the information. Say small flights dot show small flights dot count, and let me print this as well. So it will list the total number of records in this particular data frame. Okay, so just have a look. Like we are having eight, you can say, planes, small flights which are running uh, with one engine. So this is the small example, like how we can do the joining and all, based upon the SparkSQL. Now we are having certain other stuff, and like how to perform the aggregation related operations onto top of the data, onto top of this SparkSQL, onto the data what we are having. So we are having certain data, say, okay, say how to do aggregation operations with SparkSQL. Say we are having certain data, say data one is there, data one, okay, and data one is, say, we are having information, say name, say Rohit, and say we are having, say, department information, say telecom, okay, and say we are having age information, say 38. So this is first record what we are having. We are having second record as well. Let me check who is available in this particular session. Naresh, Rohit, Shivam, Swati, and Vandana. So Rahul is there. Rahul, and say department is, say R&D, and say the age is, say 30. Okay. Now we are having another record, say Swati. and say the department is say engineering, and say age is say 29, and same fashion, say Naresh, say the department is say RF, and age is say 30. Okay, now say we are having Vandana. So we are having certain records and say telecom. This is dummy data what I'm going to create, and based upon this particular dummy data we will play, and we will try to learn certain operations. Naresh, Shivam is pending. Say Shivam, and say Shivam is from say engineering. Engineering, and say age is say 31. Okay, perfect. So we are having this particular data set, and let me close this bracket as well. In the same fashion, what we are having a data set 2, data 2, and over here, like we are having uh, certain another, you can say, things with respect to this particular data set, or you can say we are having two files. In two files we are having the data with respect to these particular employees, say uh, say say telecom, and say what we are having inside telecom, what we are having telecom, say inside telecom, say we are having say telecom engineer, and then telecom engineer, and R&D. Inside R&D, say what we are having, say data scientist. So these are say like designations what we are having with respect to say departments, and with respect to say engineering department, what we are having inside engineering, we are having say engineers. I'm just mentioning like this is certain dummy data only, engineer. So telecom engineer, R&D, 1 2 3, RF is pending, and what we are having at the end, say RF is there, and inside the RF what we are having, say RF engineer. Okay, so this is the data what I'm having, and we want to play with this particular data. Let me try to copy and paste it. So, let me create another, you can say, file, and give a name, say day 12, sorry, week 12, day 18, and distributed processing with PySpark. -2.
Hello, Ashokji.
Mm-hmm.
Can you please paste that unique column which you previously?
I'm not
Unique.
able to hear.
Hello, am I
Yes,
audible?
yes, yes. Yes, yes,
Actually,
tell
you
me.
in this code, na, can you please share me the unique column line?
What you want?
I need a unique column line in this code, like you have right, na, in this
You
this
want this
last one.
particular line, na?
Like this one only.
Okay, we'll
Can
share.
you please share? Okay, okay. Please share. In chat box only you can share it.
Yes, yes, I will share in chat only. Yeah. So what we are having, we have created a particular Spark session, and we are having the data over here. What we are doing, creating dummy data, creation of say dummy data. Okay, and let me copy and paste that particular data what we are having over here. So okay, let me do the correction. uh, huh. Okay, so data 1 and data 2, that is there. Now say schema 1 and schema 2. Schema 1, and that will be say over here what we are having. We are having say name, that department, and what we are having the third column with respect to schema 1, that is age. Age. Okay, that is fine. Schema 2, and with respect to schema 2, what we are having department and say job title. So department and job title. Okay, that is fine. We are having two schema and we are having two data set. Let me create the data frames onto top of this particular data. Say data frame 1, that is create data frame, spark dot create data frame, and what I can give data 1, and I can give the schema equal to schema 1. Okay, so data frame 1 is created. In the same fashion, I'm going to create the data frame 2. So data frame 2, and what I'm going to do, instead of data 1, I'm going to pass data 2, and inside the schema I will give the schema, say schema 2. Okay, so let me try to list or display say data frame, these two data frames dot show, and say data frame 2 dot show. That is fine. Now let me try to do the execution. So current file, perfect. So the execution has been started. And the main agenda is like we are going to learn certain aggregation related operations. So for that perspective only, what I have done, I have created this particular dummy data frames, and based upon these particular dummy data frames, we will be going to run certain operations or aggregation functions. Perfect. So this is the output with respect to data frame 1, and this is with respect to data frame 2. And what is the common stuff in both of these two data frames? We are having department related things. Like department is over here as well, and inside this particular data frame as well. So if we can do the joining, so based upon the department we can do the joining, and we will be able to get the job title related information. Okay, so that is fine. Now what we are having certain departments. Okay, telecom, R&D, engineering, and RF. These are the departments what I'm having. Now what I'm doing, what I'm going to do, I'm going to calculate average is based upon departments. So I just want to calculate like what is the average is in telecom department. What is the average is, say if I'm having say 100 persons, and the age is say 30, 34, 50, whatever. So all the age divided by 100. So that will give me the average age of that particular department. And for that, like I'm going to leverage the average functionality. Average, you can say, function from the SQL side. So in order to, you can say, work with SQL, what I need to do, I need to create the temporary view. So dot create or replace temp view, and I can give the view name, say employee data. So that is the first view or first table I have created. And in the second, you can say data frame. For the second data frame, I can give the say department. Department, not department, say job titles. Job titles. Okay. So employee data and job titles, these are two, you can say, temporary views or two tables. Now what I want to do, I want to do the calculation based upon these two tables. Now how I can proceed? So let me first do the average age calculation. So what I'm having, do I need to do the joining for calculating the average age based upon department? Do I need to do joining of these two data frame? Average age based upon department. Do I need to perform join? For that, I'm asking to all of you, if I need
Yes,
to
sir.
calculate average age based upon department, do I need to perform joining?
No.
No, sir. No.
No, that's correct. So because like department is there, age is there, I need to perform, I need to like calculate age, average age based upon department. So why I need to do the joining? So I can proceed with one table only, employee data. Okay, so spark.sql, and what I can do, say select, and what I'm going to select, say department, select department, and then what I need to do, average of is, average of what is, average of is, and I can give a column name, say as average age. That will be alias over here, average age, and from like select department, comma average age as average age from employee data. Then what I need to do, group by what department, group by department. So it will be going to like group the you can say it is going to group by just whenever you are going to write the SQL query, try to you can say read it from the last. So group by department. So whatever I'm going to do in this particular query, so I'm going to group based upon the department, and so it is going to group based upon department. And what it is going to do, like it is going to calculate the average of age, and it is going to calculate like it is going to have two columns. So let me give a data frame name over here, say dot say calculated df, or you can say average age, average age, and average age dot show. Okay, so let me do the execution. So I'm going to group by department and calculating the average of age and giving the alias as average age and selecting department and average age. So it will give me two columns. Okay, department and average age. Okay, and just have a look. So the execution has been started. The first data frame, second data frame, and now we will be able to get average of age. So the average age for telecom, that is 33.5. Inside the engineering we are having 30, and for R&D it's 30 and RF is 30. So probably we have given the age in such a way, so the average is almost the same. So what we have done over here, we have applied the aggregation, say average, and over here like we have done the calculation based upon SparkSQL. Previously we have done the same stuff with data frames. Now we are doing the same with SparkSQL. Now what I want, okay, what I want to do the joining of these two tables, like employee data and job titles. And I just want to have, say, like name, the department, the age, and job title as well. I want to have that particular information as well. So how I can do that particular stuff? So spark.sql, and say I want name and job title only. Say spark.sql, and what I can do, say select, and what I can have name, select name, comma, say job title, or say what is the stuff, job title, job title. Okay. From employee data, join what, join with say this particular job titles table, join, you can say job title on what, on say employee data dot say department, employee data dot department, that is the you can say reference column, employee data, and equal to say job titles job titles dot department. Department is the reference column. Okay, so let me try to copy and paste it over here. Okay, so select name job title from employee data, join job titles on employee dot department equal to job titles dot department. So that is the query what I'm going to run, and then it is going to give me say joined data frame, join data frame, and on join data frame I can say have, I can apply say show dot show. Okay, let me do the execution. So what I'm doing over here, I'm going to like get name and job titles from employee and job titles, employee data and job titles data frame or tables, and that for that like I need to perform the joining, and like post joining I'm going to show all the records. This is like how the Spark SQL is working. First data frame, second data frame, then average age based upon the departments, and now like what we are having, say Rohit, Swati is their engineer, Shivam is engineer, Rahul is data scientist, Naresh is RF engineer, Rohit is telecom engineer, and Vandana is also telecom engineer. So what we are able to get, say the name and job title related information based upon the SQL query. Yeah. So over here, like say you have done certain stuff with respect to the data frame. So same thing is possible with data frame as well. But over here, like what we know, SQL is somehow simpler than other programming languages, and we will be able to write the complex queries over here in order to perform the operations. And once we are able to, you can say, perform, we will be able to get the outcome. So the person who is having the SQL knowledge, who is having good understanding of SQL, he can be the master of Spark, PySpark or Spark. So what I suggest, you need to like go through with certain SQL tutorials. Okay, if you like, there are multiple sites. Try to go through with simple commands like select star, append, and update related stuff, and how to perform the aggregation with the help of SQL. So you will be able to get the understanding. These are, you can say, simple operations what we have performed, but based upon the day-to-day requirement, like we can have certain complex queries as well. So this is the way how to leverage, how to utilize SQL in our codes. We will be running certain complex queries as well, but uh, for this particular session, I think from the Spark SQL perspective, that is more than enough. And just try to like do this particular practice by yourself, and try to write down the simple codes. You will be getting a particular assignment as well in order to get the flavor of Spark SQL commands, and then we will proceed with the complex queries as well. So what we have done, like we have seen how to create a temp view onto top of data frame, and create that particular temp view will act as a table. Now onto that particular table, we will be able to perform the different operations. Whatever we want, we can do with the help of Spark SQL. Sorry, with the help of Spark SQL, and then finally we will be able to write it with the standard data write API. Okay, so this particular calculation is very simple once we are leveraging Spark SQL for data processing perspective. Just have a look and ask if you are having any doubt. Just have a look, friends. Is there an issue?
I think I'm good.
Okay, so let me try to give certain more insight, like how we can utilize SQL efficiently. So instead of say employee data, let me mention say employee data as E. Okay, I'm going to give certain alias, job title as J. Okay, and then what I want E dot name that is there from the employee table. Job title is from say job titles table, J dot job title. Employee join with job title J on say E dot department and J dot job title. J dot job title. J dot department. So J over here will be the job title table and E is nothing but the employee data table, and it will give me the same outcome. Just have a look. Okay, so the same stuff like what we have seen, but over here, like we are having the information, say name is from employee table, job title is from say job titles table, employee is acting as employee data is acting as a E. Okay, job title is J, and over here we are just instead of say job employee data dot departments, we are mentioning say E dot department and job titles J dot department. So the same outcome we are getting from this particular query. This is like a little bit simplification of the code what we have written in previous execution. Okay, hope you are able to get the information. Is it fine? Are you able to get the understanding?
Yes, yes.
Perfect.
Yes, sir, it's fine.
Because it will remove the ambiguity of this table also. If there
This is
is to
a
like
little
if
bit
this
simplification on to top of that.
because if the table is having like two same name columns, so then it is difficult to find out like in SQL that
Yes, yes.
which
Sometime
column
like say
it will
department
show
dot
some error.
department, department
It
dot
will show.
department. You will not be able to get like which one is the column name and which one is the table,
Yes, yes.
Okay, so this is like giving a little bit simplification of onto top of the code that you have written, So let me start another topic. That is, you can say repartitioning and coalesce. So repartition coalesce. So these are like very important topics from the interview perspective as well. What is happening in Spark world? Like we are performing the execution in terms of partitions. Like say if we are having a particular uh, application. Okay, so if we are having a particular, you can say application that will be, you can say having application, then we are having say job. Okay, and say that will be divided into stages. Stages will be having say task, and task will have say partition. Okay. So this is the normal, you can say, execution flow what we are having. So what is happening in the Spark world? Like partitions are given to the cores. Okay. So partitions are given to core, or you can say CPU, in order to have the execution of that particular partition. Basically, like what is happening in Spark world, like multiple machines are working, and if multiple machines are working, then data will be distributed among different machines, and if different machines are there, then definitely like data will be, you can say, there in terms of partitions and all. So what is happening, say I am having say 1000 node cluster, and I'm having say 1000 node cluster, and say I have created say 500 partitions. 500 partitions are there, and say data was there say 100 GB, 100 GB. So at this moment, say 100 GB data is there, and 1000 node cluster is there, and 500 partitions are there. So 500 partition, that means like these particular partitions, say, just try to think like you have given these 500 partitions to 500 machines, because like each machine is having say one partition. So 500 machines will be utilized from here, and rest 500 machines will be sitting at ease. Those particular machines will not be performing anything. So that is a drawback basically. Like say I'm having the huge cluster that is of say 1000 node, and I'm having 500 partitions only, and I'm killing the, you can say, parallelism basically. Like it may have like 1000 machines were utilized, but at this moment only 500 machines are utilized. So the execution will take, you can say, long time at this moment. So what I can do, I'm having a particular concept that is repartition, and repartition is going to increase or decrease the number of partition based upon our requirement. So if like 1000 node is there, say I can increase 500 to 1000 partition for that particular data, 100 GB data. And at that moment what will happen, like all the machines will be utilized, and I will be able to get the outcome with low latency, and that is nothing but one way of optimization. um able to do the execution with low latency, and that is possible with repartition only, like with the increase by increasing the number of partition. Now what is happening, say just this is one case, like cluster is, you can say, having more partition, and you are having, you have created less partition. Cluster is there with heavy size, and you are having less number of partition. At that moment all the machines will not be utilized. Let me mention over here one issue. One issue, like cluster is having good amount of resources, but you are not using all resources, all of them. This will increase certain cost of execution. Cost, like it will be having more latency, and once the latency is more, then definitely that particular execution will take time, and time, that is nothing but cost over here. So this is the first issue. First issue, like the cluster, you are not leveraging, you are not utilizing the entire cluster. Second issue, what we are having, say we have created this first, try to understand the stuff, like you are having initially say 100 GB data. Okay, that is like 100 GB data was there initially, 100 GB data was there initially, 100 GB data was there, 100 GB. But what you have done, you have done filtration, okay, filtration, aggregation, okay, removal of columns, that is nothing but pruning, column pruning, okay. And based upon that, like this particular data which was initially 100 GB, now it is reduced to what, say 5 GB only, okay, 5 GB only. So initially, once you are having say 100 GB data, 100 GB, you can say in 100 GB, probably like we can have say uh, say 8 partition, or 8 blocks. So 8 blocks, or you can say 8 blocks or 9 blocks, it will be the number, and say 900 partition onto the 100 node machine. So that is fine. Now we can leverage maximum number of loads. But now the data is there only say 5 GB, because like you have done certain filtration, aggregation, removal of column, this particular stuff, and that is nothing but what we are doing in this particular second phase, some processing. We are like say we are having say 5 columns, and we are applying aggregation, like we are having say row counters, and based upon those particular row counters we are calculating certain KPI, yeah, that will be the end output, so the data, once you have started, it was 100 GB, but now it has been reduced to 5 GB only. But 5 GB, and you are having say 100, or you can say 1000 partition, 5 GB data and 1000 partitions. You try to think in that way, try to look in that particular direction, say in each and every partition you are having less amount of, you can say, information, actual data is very less. And what is happening, try to recall that particular diagram. Say you are having a client, and client is going to say RM, resource manager, and resource manager is going to say initiate, say we are having node manager nm1, and nm1 have application master and say driver, and say node manager 2, nm2, we are having say nm3, node manager 3, node manager 4, nm4, nm5, and nm6. So say this is the stuff what we are having. This is say a Spark cluster. So try to recall the stuff what we have learned. So the client came to resource manager. Hey, resource manager, I want to do the execution of this particular application. So it is going to say it want this particular client wants to do the execution of this particular application. Now the RM, it is going to do what? It is going to initiate an application master in one of the node manager, and the application master is going to then bargain the resources with respect to the load of that particular application, and it will ask say, hey resource manager, for the execution of this particular application I need to have say 4 executors, say executor 1, executor 2, E2, E3, E3, and E4. And it is nothing but say certain containers. Containers, that is nothing but combination of memory and core. So say it was the this application master was bargaining resources, and based upon the request, the this resource manager has given, say you can have 4 executors on node manager 2, 3, and 4 and 5. So at that moment, this application master, what it will do, it will going to, you can say, provide the information, and the application will be start executing onto these particular executors. Now what is, this is the, you can say, the simple say 6 node cluster, but try to think like we are having 100 node cluster, 100 node cluster, and these particular, you can say, executors are having partitions, say p1. So the executor 1 is given, say p1, and p2, p3, and p4. Say 4 partition was there initially. But suppose if we are having 1000 executors, and 1000 executors are having very less data, and like we are having a lot of partitions, because like we are having huge partitions, it might be possible say one executor is dealing with say multiple partitions. Depends upon the available or number of partitions in that particular for that particular application. It will depend. It is not like say each executor will have only one partition. Actually what is happening, based upon the cluster, the partition, like once we are having an application, then the partitioning is done, and then like based upon the cluster, those partitions are given to the executors. If you are having say small number of executors, then one executor can have multiple partitions, but those particular partitions will be executed in sequential way. If like one executor is having multiple core, then one core is going to handle one partition. Say we will discuss in detail, but just try to think like one core is utilized in order to do the execution of one partition. So might be possible like if 5 core are there, 5 partitions are executing simultaneously. Now, the thing is that if you are having 1000, you can say, partitions, and you are having very less data in those particular partitions, then this application master needs to monitor all of those 1000 partitions. If data is high, that is fine, like there is no another way. But if the data is very less and still the application master needs to monitor all the 1000 partition, that is, you can say, not a good practice. That is going to add the latency. You can think in that way, like if you are the contractor and you are having certain labor, and you can think in that way, like you need to pay to those particular labors. This particular application master is need to pay to all the labors. Like if he is this application master is going to pay 1000 labors, okay, then that will take more time. If it is going to pay for like for their work, it is going to pay for say 5 labors only, that will take less time. So if that particular work is like if that particular work can be done with say 5 labor only, and we are adding 1000 labor at that moment, then definitely it might be possible like execution is done very fast, but in order to pay those particular 1000 executor partitions or executor, the application master need to like uh, have more time, and that's why like the latency related stuff is there once we are having small data, and a lot of partitions or a lot of executors are being, you can say, utilized, because this application master needs to do the monitoring of those particular uh, partitions or executor, whatever you want to take, because like partitions are at the end executed at the executor level, and like whatever the course we are going to give to a particular executor, that much of partitions will be executed in parallel in these particular executors. So what I want to say over here, if you are having less data and you have given more number of partitions, then we are going to add latency in the system. That is you can say that is the costly stuff, and we need to think in order to optimize that particular stuff. And for that also we are having what, we are having repartitioning. So increasing the number of partitions when we need to have parallelism, and decreasing the number of partitions when we are having less data, because if we are adding more partitions to the less data, that will add latency. Okay, because at that moment certain control information need to be maintained. Each and every partition will have certain address, certain execution state that application master needs to monitor. And in the inside the Hadoop 2 we are having this application master related stuff, and inside the Hadoop 1 this was the killing, like this uh, resource manager or resource manager was not able to monitor all the jobs. Resource manager was the only guy, or you can say name node was the only person who was monitoring all the application. Then because of that, like it was failing. Okay, so over here as well, like if less data and more partitions are there, that is you can say the costly operation we need to think to optimize. And that's why like we are having repartition and coalesce for optimization of the partitions. Just think for a minute and ask if you are having any doubt on to repartition, why we need to have repartition, why we need to increase the partition, why we need to decrease the partition. Think for a minute and ask if you are having any doubt. All of you, Rohit, Swati, Vandana, Shivam, Naresh, Rahul.
So can you just explain this once again? Like I'm a bit confused in both of these.
What is the confusion? First, you need to tell me that.
Okay, repartitioning is the place where you are having a good amount of data and it is being partitioned again and again. Means high partitioning is there. And Kohli is like, what is the use case of both of it? Like where we can use
So,
it,
so,
how to use
let
it.
me ask. Let me ask. Okay, let me ask. So, say if you are having 10 partitions and 10 partitions of the data, and if you are having say 40 node cluster, then is it a good practice? 10
40 node
partition,
cluster.
40 node cluster, 40 machines are there. Say one partition is executed by one machine, one node. So 10 partitions are there, and you are going to do the execution of 10 partition with 40 node cluster. So is it a good
Hmm,
practice?
no, like half of the things will be sitting idle.
So at that moment, what you need to do? You need to increase the number of partition. Is that clear?
Okay, yeah.
Okay. So that is first thing that we have discussed. Second, now you are having say 40 node cluster and you are having 40 partition. 40 partition, 40 node cluster with respect to parallelism, that is perfect. but those particular partitions are not having data. If the data is very less and you have created 40 partition, so this application master need to monitor all of those particular partitions. It need to monitor all of those particular 40 nodes, right? So at that
Yeah.
moment, monitoring will take more time. That is what we
Yeah.
are adding latency. If you are having huge data, that is fine. There is no another way. But if you are having less data, why, like why you are not going with decrease the number of partition? That's what I have said. If you are having huge data, 100 GB data, increase the partitions. If you are having 5 GB data and still you are running with 100 partition, 1000 partition, that is, you are adding certain latency in terms of monitoring and all. That's what we have discussed. Is that fine?
Yes, sir.
Okay, perfect. Anyone else? Anyone else having any doubt with
No.
respect to repartition? Shivam, Rahul, Naresh, Vandana,
No, sir, it's fine.
No, sir, it's okay.
repartition. Okay, perfect. So the concept is clear, like why we need to increase the number of partition and why we need to decrease the number of partition. Now, how to get the number of partitions? So we are having certain parameters. Parameters to get the number of partitions. Okay, so let me take this particular code only. So data frame, say data frame 1 and say dot to dot rdd. So what I have done over here,
Data
this
frame
was
to
the data.
RDD conversion.
Yes, data frame to RDD conversion. Get num partitions. And let me print this as well. So I'm going to get the number of partition. So get num partition is a function which is, you can say, available inside the RDD. So what I am doing over here, I'm converting RDD to data frame to RDD and then trying to, you can say, calculate the number of partitions. Okay, so for this particular, say, data frame df1, so we are having, say, 4 partitions. That is, you can say, by default, default given by this Spark. And Spark. Now, what I want to do, I need to say increase the number of partitions. So
No, Ashok, this you done by RDD. So if I want to see by directly in data frame, then
no, with data frame you will not be able to see.
so this
Okay.
partitioning functionality is only available with RDD.
No. Repartition and the repartition functionality is available into both, but to get num partition that is available in RD only. Okay.
Okay.
Okay. So data frame 1, say data frame 1 to repartition. Repartition, and say initial 4 was there. Let me try to do 10 partition. 10, and that is fine. And let me give a name, say partition df, partition df, and repartition to 10. Then I need to, let me try to check the number of partition of this particular data frame to RDD. Then get num partition, and let me try to print it. So what I have done, initially I have checked like what is the total number of partition for data frame 1. Then I have done the repartitioning of data frame 1 and converted into 10 partitions, and I have given it to say new data frame, that is partition data frame. And then I'm trying to check the total number of partitions inside the partition data frame. Is that clear? Is that clear?
Yes.
All of you? It's very simple. Like I have, I'm trying to calculate total partition. Then I'm increasing the number of partition, and then what I'm going to do, I'm going to list the new partitions and how many new partitions have been created. Let me do the execution. Okay. The execution has been started. Okay. So initially 4 partition was there, and I have done the repartitioning, and now like I'm having 10 partition after repartition. Now let me try to do another stuff. Say partition df was there, and I'm going to do say repartitioning, and say I'm going to convert to 6, and then say resized, say sized the data frame, or you can say decrease partition, decrease partition, decrease partition. Let me remove data, and onto the partition df I have done the repartitioning, and now 6 partitions will be there. And let me try to print dot say rdd and dot get num partition, get num partitions, and let me print that as well. Print. Perfect. So what I have done, initially I was having 4 partition, then I have increased the partition to 10. Now what I have done, I have decreased the partition from 10 to 6, and then I'm going to print those particular decreased partition. Just have a look. Okay, so what you are able to get, Initially 4 partition was there, then you have increased the partition, then you have decreased the partitions. So this is fine with respect to say repartition. We are able to increase and decrease the number of partitions. Increase and decrease the number of partitions. So what I can do now, what we are able to see, repartition, and with respect to repartition, this is the stuff what we have seen. There is another, you can say, function or method. Based upon that as well, we will be able to do the calculation. This is repartition. Repartition. So initial partitions, increasing partitions, getting the number of like partition after increase, then decreasing the partition and getting the number of partitions after decrease. So that's what we have done with the help of repartition. We are having another, you can say, method, coalesce. Coalesce. So this is also utilized in order to change number of partitions. Say, just have a look. Say if we are having 6 partitions, then dot coalesce and let me say mention 2. I want to have 2 partitions and say coalesce partitions. Coalesce partition. Then on decreased partition, I'm going to apply this particular function. Then onto the coalesce partition data frame, I'm going to convert it to RTD. Then get num partitions, and I'm going to print that as well. Print these particular partitions as well. Okay. So the execution has been started, my friends. For initial partition, increased partition, decreased with repartition 6, and now decreased with coalesce 2. Okay, so we have utilized we have reduced the number of partition to 2. Now let me try to run let me try to increase the partitions. Repartitions, sorry, coalesce partition dot coalesce coalesce and say let me 6 and increase with coalesce. Increase with coalesce and increase with coalesce dot rdd dot get num partitions, and let me try to print this as well. So what I am trying to do over here, previously like I was having certain partitions, I have increased to those partition to 10, then from 10 to 6 I have changed with repartition. So what I have I am able to see repartition is able to increase the partition and decrease the partition. Okay, like 4 to 10 and 10 to 6 it has done. Then we have applied coalesce onto these 6 partitions and change it to 2, and let me try to increase 2 to 8 with coalesce. So over here, say coalesce functionality. Coalesce functionality. So this is the coalesce functionality what we are having, and this is a repartitioning. This is repartition functionality. Functionality. So let me try to say mention in this particular way. Say increase with repartition. Increase with repartition. Then over here decrease with repartition. Decrease with repartition. Over here say decrease with coalesce. And over here what we are trying to do, increase with coalesce. Okay, let me do the execution. Hmm, initial partition. Okay, so I have given certain, you can say, comments or description inside the print statement that will give you more insight about the stuff that we have done.
So Ashok, using coalesce, we can increase the partitions also.
Just a minute. That's what I want to give you. You will be able to comment. Initial partition for initial partition 4, increase with repartition 10, decrease with repartition 6, decrease with coalesce 2, and increase with coalesce 6. Okay, so that's what we need to see on what we have executed. Okay, let me try to print certain more things over here. Print spark dot spark context dot uh, default parallelism. Print spark dot spark context dot default min partition. So let me do the execution once again. Okay, So the execution has been started. Okay, so just a minute. Things are not proper. Hmm. So we are able to we are trying to conclude like repartitioning is going to increase and decrease the number of partition. That is fine, but coalesce is going to decrease the partitions only. However, like you are going to mention like coalesce in order to increase the number of partition, that will not be possible, no? So just have a look, over here what we are having, initial partition were 4, just have a look over here, the initial partition, initial partition what we are able to get, initial partition 4, then what we want to do onto the initial partition, this was the data frame, data frame was having 4 partitions, initial partitions, but we have done data frame 1 dot already dot get num partitions, so we were able to get 4 partition, initial partitions, now 4 partitions are there inside the data frame 1, but what we are going to do, we are going to increase the partitions, like with coalesce we are trying to increase the number of partition to 8, but it is going to give me 4 partition increase with coalesce, that is 4 only, so it is not going to like change, so what was happening inside the previous, you can say, execution. Okay, so once like we were, you can say, increasing, once we were having this particular data, like decreased partitions and the partitions were 6, so 6 partitions was given to coalesce, so coalesce was able to, you can say, do the, you can say, processing with respect to decrease, but same is given for increase as well, same number of partitions are given for increasing, so it is taking the input from here, not from here, so that's why like we were able to get 6 partitions over here, like this particular command is there, say coalesce 8, we have not changed it. So either it should have given 8 or it should have given whatever it was getting. So it was getting 6 partitions from the previous execution, and that's why like we were able to get like 6 partitions only once we were trying to increase the partition with coalesce. So what we are able to get, coalesce is coalesce is able to decrease the partition, but it is not able to increase the number of partition. Increase the number of partition. However, if we are mentioning coalesce for increasing the number of partition, then query will not throw any error. However, nothing will happen. Huh? And that's we have concluded. Huh? So decreasing was working perfectly with the help of coalesce. We were able to get the decreased number of partition. Okay, but once we are trying to increase the number of partition with coalesce, coalesce is doing nothing. It is going to pass whatever it is getting. So coalesce is not able to increase the number of partitions. And what is there with respect to repartition? Repartition is able to decrease and increase and decrease. Increase and decrease the number of partitions. That is fine. Okay, so that is with respect to repartition. Repartition is able to increase and decrease the number of partition, decrease the number of partition. And coalesce is able to decrease the number of partitions only. However, if you are going to mention coalesce for increasing the number of partition, it will take that particular query and it will not throw any error, but nothing will happen on to top of that. So that is, you can say, coalesce and repartition. Now you need to tell me that repartition is also repartition like is utilized increase and decrease, and coalesce is utilized for decrease only. So for decreasing the number of partition, where we are using, we are having repartition and coalesce. So which one is better among these two? For decreasing the number of partition, we are having both, repartition and coalesce. But which one is performant? Which one is performant? What do you think? Which one is performant? Which one is performant for decreasing the number of partition?
It's coalesce
Coalesce is performant. Why? Swati, coalesce is
because
performant. Why?
there is no aggregation.
Mm-hmm.
Um,
Mm-hmm.
Because it is not dividing the table like it, the same amounts, it will decrease the partitions only. So I think it is more.
Come again?
Like in repartitioning, if we want to uh, increase the size of num partition, so it will same size of table it will create. But in if we want to
Hmm.
decrease the size, it will so it will not work like that. It will uh,
That,
decrease the coalesce, and there is no aggregation because of that. It is much performant than uh,
hmm.
decreasing this partition.
That is fine. Huh? Partition 1, partition 2, partition 3, partition 4, and partition 5 and 6. Huh? Okay. So we are having certain data. Let me mention data in this particular way. This is nothing but say data what we are having. Huh? Okay. Data is there. Huh? We are having six partition. Okay. So now what we need to do, like we need to say do the repartitioning. Say repartitioning, say like we need to say decrease the number of partition, and say we want repartition to say 4. Okay. So once we are having this kind of data, and we at that moment, like we are going to reduce the number of partition based upon repartition clause. So at that moment, the repartition, it will try to create the equal amount of partitions. It is going to maintain, it is trying to maintain the size of each and every partition almost similar to each other. So what will happen, say you have done the repartitioning, so it will look like this. Say this will be the outcome. Once you have done, you have applied the repartition clause. So this will be, it will always try to maintain the same size, you can say almost the same size partition. That is happening with respect to repartitioning, and for this particular task huge shuffling will be there. Huge shuffling of records will happen if if repartitioning is there. Repartitioning is applied to decrease the number of partition. Okay. So it is always trying to have almost the same size of partitions. So what we were having six partition initially. We were trying to you can say have four partition out of these six partitions, and we have applied repartitioning clause from the PySpark side, and it has, you can say, it has tried to maintain almost the equal size of partition. So that is fine, but huge shuffling is there. But once you are going to do with the help of coalesce, then coalesce is working on coalesce. Coalesce is working on data locality principle. That is working on data locality principle and tries to minimize the shuffling. Shuffling. However, shuffling will be there. It can't avoid the shuffling, but it will be always very less if we compare it with repartition. So it might have, you may have this kind of, you can say, data, like it might be, you can say, look like this. Okay, you may get this kind of data once you are going to apply, say, coalesce. So however, we are having unequal size, the partition of unequal size, but the main idea, in order to have this particular reduction in partition, that always shuffling will be very less. It should have less amount of shuffling. And shuffling is an operation which is very costly in nature. We always think to minimize the amount of shuffling in big data world. So this is like the repartition and coalesce. Repartition and coalesce are utilized to change the number of partitions. However, repartition is preferred once you need to increase the number of partition, and coalesce is preferred once you need to decrease the number of partition. Coalesce will give you unequal, you can say, partition, but it will try to minimize the shuffling. Repartition will give you almost equal size of partition, but it will be impacted with heavy shuffling of records. A lot of records will be shuffled once you are going to leverage repartitioning in order to decrease the number of partition. So that is repartitioning and coalesce. And how we can do with the help of that, like the clause like dot repartition, df dot repartition, and we just need to mention the numbers, and df dot coalesce, and we just need to mention the numbers with which we need to decrease the number of partitions, and df dot repartition and the number by which we need to increase the number of partition. That's very simple. Programmatically, that's very simple, and we have seen like the increased number of partitions and decreased number of partitions as well. There are two other parameters what we are able to see, say default parallelism and default main partition. So default parallelism, that will be based upon the processing capability. Okay, and these are, say default parameters, and these are, you can say, set it automatically. If you want to change, you need to change inside the configurations of Spark configuration, you need to change these particular parameter. And min partitions, like if you are loading any data, at least two partitions will be there on to top of that particular data. At least two partition, it is going to give you at least two partitions. So these are like certain parameters by which we can like get the information about the cluster, and at that moment, like we will be able to improve the latency by increasing or decreasing the number of partitions. Just have a look and ask if you are having any doubt. Just have a look, all of you.
In last, you printed this default parallelism and default mean partitions. So these are just to view that what is the backend parameter setting for this one. Nothing ready to
Based upon
process.
the cluster configuration, let me try to give you certain other stuff. Just so in my machine, say I'm having two cores and four logical processor. Okay, so based upon this particular, you can say, machine configuration, four logical processors are there. So for this particular machine, I can handle four partition at a moment. So default parallelism, I can run four partition in one go. Okay, and default min partition, like this is the bare minimum partition what I like. This is the total capability, like I can handle this much of partition in parallel, and this is like the minimum, like at least two applications will be running in parallel onto this particular machine, so two, that is divided, that is declaring say at least two partitions will be running, at least two partition running, and default like max this much of the partition, or you can say max this much of application will be able to run in this particular cluster. Okay, you can set these particular properties in order to increase the parallelism, or increase the minimum partitions. Like if data is very heavy, then you can have like 10 main partition, 20 main partitions. At least this much of partitions will be there if you are loading any data in PySpark, right? So these are like certain system configuration which we are going to print with the help of these particular commands, right? However, this is the simple stuff only, and these are not creating major issues or major challenge, because we are after like we are, you can say, overriding these properties with repartition and coalesce. Whatever we are getting, we are trying to increase and decrease the number of partitions. Okay, initially, like if you are not playing with these parameters, so you can have the to you can set these particular properties in order to improve the performance. Try to think in that way, this coalesce and partition will override these particular properties, it is not like, it will not make any sense if you have four partitions, or like four main partition or two main partition, but based upon this coalesce and repartition, you can increase or decrease based upon cluster configuration and the size of data. So you can override the system properties or default properties. Is it fine, Rohit? Clear?
Yeah, yes.
Perfect. Repartition and coalesce. Now let me start a new topic, and then we will proceed, and in tomorrow's session we will complete that particular topic. Okay, so the next topic is cache and persist. Cache and persist. And persist. So say we are having data frame 1, and we have done certain processing on to top of this, and we are having say data frame 2, then we have done certain transformations, actions, whatever, certain operations, then data frame 3 is there. On data frame 3 I have performed certain operations, then data frame 4 is there, data frame 4. So in this particular way, say I'm having multiple data frames in a particular code, and now data frame 4 is there where I need to perform maximum query. Perform max query. Max query. So onto this particular data frame, I'm going to perform max of the queries, and what is happening? Like Spark is what? Spark is lazily evaluated. Like if I'm going to perform any another, you can say action. Say onto this particular data action, say one, or you can say operation. Let me action can confuse you. Say operation one, operation two, three, four, 2, 3, 4, 5, 6. Okay, so n number of operations you are going to perform onto this particular data. But what I have mentioned, Spark is having lazily, Spark code is lazily evaluated. If you are going to perform any operation, then what it will do, it will start from the end that is based upon say DAG. DAG. A DAG is there with respect to the code that you have written that is directed a cyclic graph. So based upon that particular DAG, the execution will start. At that moment, what will happen? So it is going to check like what is data frame 4 and how it got the data frame 4, like based upon the data frame 3, data frame from data frame 2, and data frame 2 from data frame 1. That is the base data frame basically. You can like instead of you can state a frame, you can mention RD, so same functionality will be there. So data frame 4 is the child data frame for data frame 3. Data frame 3 is the child for data frame 2, and for data frame 2, the data frame 1 is the parent data frame. Okay, so we are having parent and child relationship over here. Once a particular operation is there, then based upon the DAG, the execution will start, and it will start from the very first step. At each and every operation, the execution will start from the beginning and it will provide me the outcome. If the second operation is there, then the same thing will happen, like all of these particular steps will have the execution and I will be able to get the outcome. So what is happening? The execution is happening again and again. If I'm performing any operation, then like all of these mentioned steps will be taken into consideration because these are mentioned inside the DAG, and then I will be able to get the output. So these particular steps are unnecessary. Unnecessary because why we need to do the execution again and again? So at this moment, what we are having two clause, that is cache and persist. If we can cache or persist this particular data frame, okay, then these particular operations will not be performed. We will be having the the data, okay, after performing these particular operations, then it will be stored on one location, and that location will be decided upon the cache and persist. So once we are able to cache this, so if we are going to perform at first operation, definitely it is going to like do the execution, but for rest of the steps, rest of the operations, it is not going to perform the operation again and again, and it will give us, you can say, very good outcome. The job will be more performant in this particular case. So caching is to, you can say, store the intermediate output. Let me write it. Caching is to store the intermediate output for subsequent queries in order to make a job more performant. It will boost the performance of repeated operations. Okay, that is the beauty of this cache and persist. Now we are having cache and persist. These are the two things. But there is like a small difference between cache and persist. Now, what is that particular difference? Let me explain that particular stuff. So cache is always inside the memory, inside the memory, and persist will have certain storage level, and it can be memory or disk both. Okay, so that is the difference between cache and persist. Cache is always inside the memory. Okay, we are storing, once we are storing inside the memory, inside the caching, we are going to like store the intermediate output on inside the memory only, and once we are like leveraging persist, then it may be inside the memory, inside the disk, or both, so that is, you can say, cache and persist, now there is another, you can say, concept, that is serialization, serialization. So inside the serialization, data stored in bytes format, bytes format, and takes less storage, storage. And non-serialization, data stored in bytes, in objects formats, and occupy more storage. Okay, so serialization and non-serialization, these are like two important properties, and which is utilized inside the caching and persisting. So serialization, what we have seen, data stored in terms of bytes, and it is going to take less storage. Non-serialization, data stored in objects format, and it is going to occupy more storage. Now, what is there? Once we are storing data, disk, on disk, data stored in serialized format, serialized format. It means like we are having data in terms of bytes on disk, that is fine, and took less storage. And on the other side, once we are having memory, okay, data stored in non-serialized format in terms of, say, objects, and took more storage, so more storage. So say if I'm having 1 GB data, and say if I'm going to cache it, or sorry, I'm going to store it on disk, on disk. So if I'm going to store it on disk, so possibly say it is going to take, say, 1 GB of space only, 1 GB space, because 1 GB disk is doing what? Like 1 GB, like it is going to store it in, you can say, serialized format, that is nothing byte, and took less storage, 1 GB, possibly say 1 GB only, or you can say 900 MB, it is going to occupy, say, 900 MB space, because like data is stored in terms of bytes over here, now like if 1 GB data is there, and I'm going to store inside the memory, okay, then possibly say it might take 1600 MB space inside the memory, because data is there in non-serialized format in terms of objects. Once I'm going to store the data inside the memory, because objects always occupy more space, and because of that it is going to take more storage, now once I'm going to cache, so it is going to occupy more space, and memory, like memory, and that is the costly component as well. Costly because Say if you are going to purchase 1 TB of memory, then like that will cost you in lakhs. But if you are going to purchase 1 TB of disk, it will cost 3 to 4,000 only. Yeah. So disk is the cheaper, you can say, component, and memory is the costly component. And over here the data is stored in non-serialized format and occupy more space. So we need to think in order to, you can say, uh, you can say, have the data in serialized format. Can we have certain techniques with the help of, like, I can have the data in serialized format as well inside the memory. So we are having certain, you can say, file for, you can say, storage levels. With the help of that, I can have the data in memory in serialized format, and that will occupy less space, and I will be able to save the memory in that particular case. So caching, persisting, and serialization, non-serialization, and like occupying more space. So these are certain, you can say, internals of caching and persisting. Now, how to apply caching? So it's very simple. Say df dot cache, and the data frame will be cached inside the memory. That is very simple, and it will be in, say, non-serialized format. It will be in object format. It will be stored inside the memory. That is fine. But once we are going to persist, persist. So persist is having certain storage level. What I have mentioned, persist. So persist is having certain storage level, and let me show you. So persist, so df dot persist, and let me mention over here. So what we are having, so we are having this particular data frame. Yes, someone was speaking. Dot cache, that is fine. Data frame will be cached. But what is there with persist? Persist. So persist, I just need to give the storage levels. Storage levels. Storage level, and storage level dot equal to storage level. So storage level dot storage level equal to storage storage level. Just a minute, huh? Syntax I need to check. Storage level dot levels. So I need to import storage levels. So from PySpark, from Spark. Because of that, like we are not able to get up from PySpark dot storage level. Storage level, import storage levels. Okay. So, storage level. Storage levels dot. So storage level, just have a look. Off if disk only, or disk only 2, disk only 3, memory and disk. So I was not able to get like why we are not able to get the dot, and equal to was throwing error. Say uh, memory only 2, and say memory and disk. So this is the storage level basically. Say say I'm having this particular, you can say, increased coalesce, increased with coalesce, and I'm going to persist, and I'm going to utilize say storage level dot uh, storage level, and I can mention in this particular way as well. Say storage level equal to okay, I can give in this particular way as well. Okay, is it working? Okay, this will also work. Storage level, or I can give in this particular way as well. Storage level, or I can give in this particular way as well. Say my storage level, storage level, and I can mention the storage level, say whatever. Say if you want this, memory and disk, to storage level dot disk. Okay, and I can mention this particular level over here, level, my storage level, and I can pass it over here as well. That is depending on you. So what I have mentioned, like I can have this persist, and what I can mention is storage level, and say storage level memory only, MEMORY, memory only. Okay, so once I'm going to persist and I'm going to utilize this memory only storage level, then cache and persist will be functioning in the same way, because the data frame will be stored inside the memory only. Okay, so there are multiple, you can say, persist level, say memory only, and memory only disk, memory and disk, say memory and disk, memory and disk only. Okay, disk only. That's what we are able to see over here. Say dot. Okay, storage level dot, and just have a look, like we are having different persist level, memory only two. So what is having memory and disk, then OFIP, disk only 2, disk only 3, memory and disk 2, memory and disk, and deserialization is nothing but non-serialized, then memory only 2, and so these are the, you can say, storage levels, these are certain storage levels inside the PySpark. So over here, memory and disk, like the data will be stored, will be cached in memory and disk both, if like we are going to use OFIP, so it will be, the data frame will be stored outside the JVM. OFIP is memory outside the JVM. Disk only stored onto the disk only too, like it is going to you can say store on disk, the data frame will be, you can say, cached onto the disk, but it is going to have two copies onto different machines. Same thing will happen, like disk only 3, like 3 copies will be there, memory and disk 2, like memory and disk with 2 copies, and memory and disk deserialization, so memory is having data in deserialized format, and disk is having on serialized format. So that, like dealing with serialized and non-serialized format, that can create certain, you can say, issue. So onto memory and disk, it is in deserialized format, then memory only, that data frame will be cached inside the memory, and memory only 2, so inside the memory with 2 replications, so these are nothing but certain storage levels, and these are there, say memory only 2, memory and disk only 2, disk only 3. Okay, OFIP, OFIP, and we are having certain another, you can say, at over here in PySpark it is not there, but we are having certain other formats, say memory only serialization, we can have data, or you can say data frame cached in serialized format, because we know, like memory is having data in non-serialized format, so if we can do serialization over here, then that can, you can say, do certain betterment, and what we are having, memory and disk serialization, same like memory and disk serialization, memory and disk SD serialization, memory and disk serialization. So we are having multiple, you can say, storage levels in order to persist the data frame inside the onto the disk and memory. So this particular thing will give you a certain, you can say, betterment in order to do certain operations. Now there is one important concept, like in order to apply caching and persisting, that is very simple. You just need to have the understanding about storage level, and you will be able to have that particular data frame inside the cache or onto the disk. You will be able to store that. But what is happening if you have used this particular, you can say, storage level, memory and disk, then what is happening? So once we are like storing the data on memory and disk, so what is happening? Some data is stored onto the inside the memory, and remaining data which is like having least use, that will be moved onto the disk. So as and when required, like it is going to have the data from the memory and disk both. But over here certain optimization is happening. Say I'm having certain data which is having list recently used and list use, basically list use. So list use means the data which is placed inside the memory is not utilized from say certain time. Then what you can do, you can you or the Spark is running a algorithm, that is LRU, list recently used. This particular algorithm is running recently used. So this particular algorithm is running, so it is going to check like inside the memory which data is is not utilized from long duration, and once it is able to identify certain blocks, then it is going to like move that particular data from memory to disk. It is going to evacuate the memory, so that process is called block evacuation. Block evacuation. Evacuation. Like removing certain blocks from the memory which are utilized less. So at that moment, like list recently used algorithm will come into the picture, block evacuation will happen, and the data from the memory will move towards the disk. And same thing is happening onto the disk as well. If like certain amount of data, certain piece of code, or the result is utilized heavily, then that will be moved inside the memory in order to have low latency. So block evacuation is a process which is happening inside the memory and disk. Once we were going through with memory management. Memory management. So during the memory management, we will discuss more about these particular things, like what is off if memory, okay, how block evacuation is happening, what is the storage memory and execution memory. So those particular things are, you can say, utilized, because what is happening inside the PySpark, the execution is happening within the memory, and if execution is happening within the memory, then storage is also happening within the memory. Then which portion of the memory is utilized for storage and which portion of memory is utilized for execution? So those particular things will be covered inside the memory management. Let me cover what we have seen in our today's session. Let me provide you a quick overview. So we have started like with the topic with Spark SQL, and we have seen, say, Spark SQL is very important, you can say, API or library what is given by Spark, and with the help of this we will be able to do the processing with SQL like queries. And how it is possible? Just by creating a temporary view onto top of the data and giving a view name. That view name will act as a table, and we will be able to run simple SQL queries. So, and we have done certain calculation like say calculating and aggregation and joining related stuff. Then we have started a topic repartition and coalesce, and we have seen that repartition is utilized to increase and decrease both, but coalesce is utilized for decreasing the number of partition. And we have seen like once we need to decrease the number of partition, we need to prefer coalesce instead of repartition, because coalesce is providing good performance. It is going to minimize the amount of shuffling. However, unequal partitions are there, but shuffling will always be less. Then the last topic we have started with caching and persisting. Caching uh, like caching or storing the data or result, which is utilized heavily, because Spark is lazily evaluated. Then we need to uh, store a particular data which is utilized heavily, and so that like unnecessary operations will not be performed again and again. And in order to do this particular stuff, two clauses are there: cache and persist. Caching will be done inside the memory, and persist can be inside the memory and disk. Then certain another stuff, serialization and non-serialization. Data on memory is always in non-serialized format, and store in the objects format and occupy more space. On disk, data is there in bytes format and occupy less space. So we are having certain storage level which are providing serialization and deserialization. And uh, then based upon our requirement, we can use any storage level, and memory and disk, that is the preferred one, because over here we are using the mixed flavor of both memory and disk. Because if memory is less and still we need to store certain data frame, then those can be stored onto the disk. However, this particular approach is having certain disadvantage, because like movement from the disk, records movement from disk will take some time, but it will definitely give you a good performance with respect to the data frame which is not cached or persisted. And once you have done each and everything with respect to like caching and persisting, then you should unpersist that particular data frame clear in order to clear the temporary space. So df.unpersist, that is another clause. Like once you have done each and everything onto top of data frame, persisted data frame, then you can proceed with unpersist. So that's it for this particular session. Let me stop recording and take your queries.